The graphics for the Nintendo Game Boy can be split into three main topics: the background tile map, the window tile map, and sprites. Each of these are rendered using 8x8 tiles that are stored in the Game Boy's video RAM, or VRAM for short. In my previous tutorial, we installed GBDK 2020 and compiled a basic ROM file. In this tutorial, I'm going to show you how to draw a basic background image. To draw backgrounds in Game Boy games, you need two different things: tile data and a tile map. The tile data consists of all the unique 8x8 tiles in our background image, and the tile map tells the Game Boy which tiles in VRAM the background should show. Before we jump into the code, I'll explain the process at a high level. Drawing backgrounds can usually be split into 4 different steps. In the first step, we simply include our background files into the Game Boy's ROM file. In the second step, we need to make sure the background tile map is visible. In the third step, we place our tile data in VRAM. In the fourth and final step, we update tiles in the background tile map. We'll start by relocating the minimal template folder from the previous tutorial. We don't want to edit this folder directly, so we'll just duplicate it. You can place the duplicate anywhere and name it whatever you want. However, if you move the folder, you'll need to update the makefile so it still knows the location of the GBDK. The minimal template has only one code file called main.c. To get started, we'll add the .c and .h files for our background to our project folder. Our makefile compiles all .c files, so we do not need any extra compilation configuration. You can find links for the background image files in the video description below. After adding our files, we'll add an include statement in our main.c for our background image. In a later video, I'll show you the 2 common ways to create background images. Next, in the second step, we'll step inside of our main function. We'll use the show BKG macro to make sure the background tile map is visible. In the third step, we'll use a function called setBKGData to populate the Game Boy's VRAM with tiles. This function takes 3 parameters: where to start placing the tiles in VRAM, how many tiles to place in VRAM, and a pointer to our background image's tile data. When we call the setBKGData function, we'll use 0 as the first parameter. This is where we want to start placing tiles in VRAM. For the second parameter, we'll use a macro that represents the number of unique tiles in our image. This macro was generated back when I converted the image to .c and .h files. If we open up the header file for our background image, we can see the macro's true value. If we compile and run our ROM file, if we look at our emulator's VRAM display, we should see all of the unique tiles from our image. Getting back to the code, the fourth and final step is to update our background tile map. For this, we'll use a function called setBKGTiles. The setBKGTiles function takes 5 parameters: the X position of our image in tiles, the Y position of our image in tiles, the width of our image in tiles, the height of our image in tiles. And the final parameter is a pointer to our background image's tile map. Our background image will start at the top left of the screen, so we'll use 0 and 0 as the first 2 parameters. Our background image is the size of the Game Boy screen, so we'll use 20 and 18 as the second 2 parameters respectively. Our final parameter is a pointer to our background image's tile map. Once done with all that, if we compile and run our ROM file, we should see our background image. In the last video, I used the BGB emulator, but I want to highlight another emulator called Emulicious. Emulicious is a free emulator that also supports live debugging via VS Code. It can run on any operating system and can emulate many different retro game consoles. Since the GBDK can compile for multiple retro consoles, Emulicious is definitely worth your time. That's it for this video. In the next video, we'll explain how to move the background around and some of its limitations. If you have any questions, please post a comment below. Alternatively, you can check out some of the helpful links in the description. Thanks for watching.